Aloha, Ruby. How's it going, guys? Everybody doing well? Good lunch? Raise your hand if you're in Hawaii right now. Not bad, right? I've been to worse conference locations, I gotta tell you. So it's interesting, I realized earlier, this is the first time I've given a talk twice in a week. So on Thursday, I gave this exact same, well, very similar version of this talk at Magic Ruby, which is in Disney World. So I flew directly from Orlando to here, so my life is rough. You can send sympathy cards to my address. So just a little bit of administration before we get started. My name is Ben Orenstein. I work at Thoughtbot in Boston, and this talk is Refactoring from Good to Great. And this is basically about things I've learned in the last year or so that I think improve the quality of my code. So I'm just going to share that with you guys. Now, I don't want you to think of this as a lecture. This isn't me standing here and telling you all these things that are absolute truth. Think of this as pairing. I'm now pair programming with all of you. So as a result of that, if you have questions, say something. If you disagree, say something. If you have suggestions, say something. I love that back and forth during the talks. Don't be shy about interrupting. I love diving into stuff. So go for that. Now, let's dive right into this. I want to show you my first example. Take a second and read this code. Now, this is based on some code I wrote recently. It's a simplified version. This is basically a very simple report that takes a collection of orders, a start date and an end date, and returns the total sales of those orders. Order has an attribute called playstat that we use to check the date range. Now, about a year ago, I would have committed this, pushed it up, and been done with it. Now, when I look at this, I look at it and I think it's about B-ish. It's about a B, B minus. It's decent. If I was pretty confident that I would never come back to this code and change it or extend it, I'd probably just say, whatever, it's good enough, push it up and let's move on to the next thing. But these days, there's some stuff I would do to improve it. So the first thing I would like to do, notice we've got this temp variable right here. We're figuring out the orders within range, we're sticking them in a temp, and then we're doing something with it. I'd actually like to extract this into its own method. I'm going to pull this into a private method. Now, I've recorded a macro that does this for me. Don't freak out. So here's the before. Temp is in that method. Here's the after. Made a private method with the same name, and I'm just referencing it from up here. So this is something I actually do a lot these days. Pull out these there's a refactoring name for this called extract temp to query. And this is something I do a lot. Now, why do I do this? Why is this worth it? Well, the first thing to notice is we've gone from one method with 2 lines to 2 methods with 1 line each. Now, I'm not going to tell you that that's always an improvement, but it usually is. I'm starting to think these days that methods longer than a line are a code smell. And I should define what code smell is just in case. A code smell is something that indicates there may be a problem. Not that there is a problem, that there may be a problem. These days, I try really hard to get down to methods that are 1 line. And it usually results in really good code because my methods are focused. So that's one win. The next is that we can reuse this. So I think it's reasonably likely, given that we have total sales within date range, that the next thing that the stakeholder will ask for is something like average sales within date range. Now, when the code looks like this, you have the logic for selecting those orders within range locked up in one method. It's more likely that I'm going to duplicate that later. Whereas if I have it like this, I think it's more likely for me to reuse it. So I think that's another win. Finally, the nice thing about this is when the code looks like this, for whatever reason, because we're programmers, because we read code, when we see code like this, we read it. So the first thing your eye does when you see, OK, orders in range equals, OK, let me figure out what this is. Let me figure out what this is doing. When it looks like this, when it's its own method, my eye is more likely to see orders within range. OK, that's just a private method. I'm just going to assume that selects all the orders that are within the date range. What's it do next? I'm more likely to ignore those details. And in fact, by extracting this method and moving it into a private method, I've given you a hint. And the hint is, this code is not important. This is an implementation detail that you don't really need to care about. If you care about exactly what's going on in that method, you can dive into it. But it's not super important to what this report is about. So I think the wins are sort of small, but in the aggregate, they're worth doing. So let's keep moving, though. I think we can make this better. Let's look at this method we created now, orders within range. And now within this method, we're asking order about things about itself. We're saying, hey, you placed it after the start date and before the end date, and then we're using that information to make a decision. Has anybody heard of a concept called tell, don't ask? OK, cool. So this is an idea. It's not a law, but it's something that can sometimes lead to better code. And what tell, don't ask is it says it's generally better to send an object a message and have it perform work, rather than ask that object about its internal state and decide what to do on its behalf. Not a law, but it's a maxim. It tends to lead to better code. This code actually violates tell, don't ask. You can see I'm trying to select some orders, and to do that, I ask order things about itself, and then make a decision on its behalf. So I'd rather actually change this code to look a little bit differently. So what if instead we did something like this? So now this sort of looks like an ask, but the logic has moved. I'm actually telling order something. I'm saying, tell me if you're placed between these two dates, as opposed to, hey, order, what's your internal status? What kind of attributes do you have? And then I'll make a decision based on that. So this is actually closer to following tell, don't ask. So I have specs for this, which I'm going to run right now. And that blows up because I used local variables when I meant instance variables. Let's do that again. OK, there's the error we want. Undefined method placeStat. We're calling a method on order. I'm effectively doing TDD by writing the code I wish were there. So let's actually add that method to order now. And we actually want not placeStat. We want place between. That's a better name. All right. So let's define that. Place between takes a start date and an end date. And then, we're going to say, is start date after? Is it before placeStat? And is end date, oh, got it backwards, don't I? Let's do this over. PlayStat, this will be easier to read, is PlayStat after start date, and is it before end date, right? So there's our place between method. Let's run the test again. We're back to green.
What about a range include?
So the question was, what about a range include? And that's a great idea, and I'm going to get there.
Okay.
Yep. We're doing little steps, but this guy's totally right. We will end up there eventually, but not quite what you said. Something a little bit slightly better. But good question. So, OK, so is this an improvement? Yes, I think it is. We've moved this logic over to order. We've stopped pulling out interior pieces of order and fiddling with them, and are instead just sending messages. This is a good OO principle to follow. Don't let the internal details of something like order leak out into code surrounding it. That's the core idea behind tell, don't ask. So I think we have a nice win here again. I'm happier with where this logic is living. But now I see now a new problem. A problem that's made evident now that we have a couple places where I'm passing start date and end date. So notice I passed start date and end date into the initialize of this report. And then I'm doing it again down here. And I have start date, end date here. This is another smell. When you have a pair of arguments, at least two, that you're passing together all the time, there's a name for that, and that's called a data clump. And now a data clump is a great hint that you should extract an object instead to hold those values. A good way to test if you have a data clump, by the way, say I have these two pieces of data, I have start date and end date. If I took one away, would the remaining one make sense? Not really, right? What would it mean to create an orders report with just an end date? Doesn't really make sense. So if these things are always going to live together, there's an implicit reliance on each other, right? It is implicit that I need a start date and an end date. Whereas if I made this thing into one object, like a date range, it becomes explicit that I need both of those. That's another great maxim to think about when you're writing your code. Imagine you have to explain your code to somebody else. Any line that you have to go, OK, well, we're always going to have a start date and an end date. Anything that's implicit in the code that you can take out and somehow make explicit and more obvious, that's generally going to be a really big win. So let's do this. And we'll start in the spec. Here's my spec. It's really simple. I have an order within range, and then out of range, and then this date range, and then I make sure that the total sales number is correct. So let's pull out a date range right now. And again, I'm going to write the code I wish I had. Come on, baby. Oh my gosh. I'm vimming too hard. There we go. And then here, we'll pass in the range. Cool so far? We're going to run this. It blows up. Uninitialized constant date range, as expected, because I just referenced a constant that's not real. Let's go make that error go away. OK. Now, there's going to be a handful of errors as I run this, right? Because suddenly, wrong number of arguments. This actually, I'm calling dateRange.new and passing it arguments, but it doesn't expect them. So let's just make a quick struct to hold the start date and the end date. And now I have roughly the error I want, which is wrong number of arguments into orders report. I'm passing 2 arguments right here. It used to expecting 3 up here. So now I need to thread this new date range through. I'm going to do this in sort of a compressed series of steps. So again, don't freak out. Let's pass in the date range. Now, there's no such thing as start date, end date. It's just date range. And same deal here in that method we wrote in order. It's just a date range. And now we need to ask the date range about its start date and end date. See if we're green again. Boom. OK. So is this a win? Yes, it's a win. I think it is. I think this is worth doing. Now, Bob Martin has said he thinks that most intermediate object-oriented programmers are too reluctant to extract classes. You should be fairly aggressive about being willing to extract small classes like this. Look at date range. It's super simple, right? It's very basic. But again, it's made something that used to be implicit in our code. Is that better? Better or worse? All right. It's made something that used to be implicit explicit now. Now date range, you know, is a pair of values. This class doesn't even have any behavior on it. But I think this is still worth doing. I've created a name for something. I've pulled out an explicit name. That's almost always an improvement. But there's another win here, which is we've reduced coupling. Now, what's coupling? Coupling is the degree to which 2 components in a system rely on each other. So if component A and component B have 0 coupling, you can change A as much as you want and in any way you want, and you'll never break B, and vice versa, right? So that's with no coupling. Let's say that A and B are extremely coupled. That means it's really hard to make changes to either one without breaking the other. Now, as you might imagine, low coupling is good, high coupling is bad. Because low coupling makes change easier. And that's what's hard about software, is responding to change. I saw a keynote by Dave Thomas, and he said the only thing worth worrying about when you look at code is it easy to change? So low coupling makes things easier to change. And let's look at a quick example of some coupling. Yeah. So there's different types of coupling. This is called parameter coupling. So notice that notify user of failure passes in an object called failure into another method. Within that method, within print to console, we call toSentence on that parameter. Now, if I passed nil into print to console, this would blow up, right? No method error. toSentence is not defined. If I passed something else, let's say an integer, into print to console, this will blow up, right? Because toSentence is not defined on integers. Or at least I hope it's not. So there's actually coupling between these 2 methods. Notify user of failure has to know what print to console is going to call on its parameter. If I change print to console, I could make notify user of failure blow up because they're coupled through the parameter. Now, parameter coupling isn't bad, but less coupling is almost always good. So something to notice is methods that take no arguments are superior to methods that take 1 because they do not have parameter coupling. First time I heard that, that blew my mind. Also, if we keep using induction, methods that take 1 argument are better than ones that take 2 And methods that take 2 arguments are better than the ones that take 3. Because in each example, we're lowering parameter coupling. So notice what happened here. We just slimmed down our argument list from 3 to 2. And that's a win. So coupling is reduced. That's one win. We've made something explicit that used to be implicit. That's another win. But also, we now have a great place to hang behavior. In object-oriented programming, it's a really good idea to group behavior with the data it operates on. And now that I look at this, figuring out if a date is between two bounds is not actually really a good responsibility for order, but it's a great responsibility for date range. I can imagine wanting to know if other objects have a date placed between two endpoints, and we can reuse date range. So what I'd like to do now is move this logic into date range. So why don't we say, what do we want this to look like? So why don't I ask date range, hey, does this include my playstat? That looks good to me. That blows up as expected because this method doesn't exist. Date. And then we'll say is date after the start date and before the end date. Let's see if that works for us. And it does. So now, order just knows how to ask something else if its playstat is included. And I like this, because order should know about playstat. I'm OK referencing this bit of data, which is on order within order. And I'm OK with date range knowing how to find if a date is between 2 dates. Perfect. That's exactly where I want this logic to live. Now this guy asked about a little refactoring, so let's do that right now. There's actually a handier way of writing this. So I can ask if start date, end date, the range, if it includes date, right? Back to green. Good. But I have a little thing that I gave this talk somewhere, maybe Scottish RubyConf, and Jose Valim showed me this. Cover? Cover or covers? Let's see. Nope. Cover. Yeah. So when you ask a range if it includes something, Ruby is going to instantiate every object within that range and then check if the object you passed into include exists in there. If you ask cover, it's just going to figure out, it's going to instantiate the 2 endpoints and then use some logic to figure out if the thing you passed in is in between this. So if we had a date range that was 300 years long, this actually could be a lot faster performance-wise. Yeah, question?
Well, I noticed when you were showing your test that you didn't cover the boundary conditions of the date, like you didn't check one day. So I don't know if you just changed the boundary conditions with that.
That's a great point. His point was that my tests aren't really thorough enough. I'm not testing the edge conditions in there. And that's actually a really good point. I should go back and improve those tests. I think you can probably trust me that it works enough for now. But yeah, that's a good thing. I'll beef up the coverage on that guy, because that's a very good point. Other questions? Yeah?
I just wanted to mention that the code smell that tells you to do this sort of extraction is feature envy.
Feature in.
That's a useful.
Good point. Yeah, so the code smell that motivates this kind of refactoring is called feature envy. And feature envy is when one class seems very concerned with the internals of another class, when it's asking it a lot of questions about its internal data and working with it. That's usually a good hint that you want to move that logic onto the class itself. The client code has envy of what that other class knows, and so it's asking a lot of questions and fiddling around with the data. Thank you, that's good. So a couple little quick things I would do now to finish this up, and then we're going to move on to a new example. So this is kind of ugly, right? This is pretty janky. When I read this, yes, I'm mapping the amount, and I'm doing this, and I'm summing in this way, but if you read this, you're just really calculating the total sales, right? So whenever I have a bunch of kind of ugly code that if I wouldn't use the words, oh, I'm going to map the amount and then inject with 0 as the default and add the sum, what I would really say if I were describing this to you is, then I'll add up the total sales. So when you look at your code and it doesn't read like you would say it, make it read like you would say it. So what I really would say is something like that. Uh-oh, where are my typo? Sorters within range. All right, back to green. So now, take a look at this top-level method. The total sales, here's the name, total sales within date range are the total sales of the orders within range. That is how I want my code to look. That's like brain dead simple, right? And this is my only public method. I'm extra aggressive about making my public methods read like this because it's really likely that someone that comes into this code mostly cares about this method. These, I'm slightly less aggressive about that. But people want to know about your public API. Your public API should be super, super clear. Your private API should be as well, but it's a little bit less important. It's less likely that people care about those details. But even so, I'm going to change this guy right here just to be a slightly quick little hack with Ruby 1.9. I don't need the ampersand? Symbol plus? Oh my goodness. So it calls toProc on that for me? Oh, that's wonderful. That's cool. Okay. So apparently you don't need to call toProc on it. You can just pass in a symbol argument, which is wonderful. Anything else? I heard some murmuring. So Corey's saying I don't need the 0, but he is only partially right. If I don't have any orders, this will blow up. And funny enough, I didn't have the 0 originally, and then in the middle of a talk, Jim Wyrick is like, what happens if you don't have any orders within range? And I was like, oh, map will bring up an empty array, and then I'll inject over it. And what do I get if I don't have I guess it'll return an empty array as opposed to 0, right?
Yeah, right.
If I inject plus on 0. Yeah. Right, if I just have this, that's going to blow up. Right, I get nil as opposed to 0. So Jim Wyrick beat you on that one, Corey. Sorry. You should see my commit message. It's like, Jim Wyrick found a bug in my talk. I was really excited. OK, so we've been working hard. So I want to show you, as a quick means of a break, my most important Vim plugin. This is the only Vim plugin I use, obviously. Not really. But hey. All right, let's move on. Let's do something different. Here's another bit of code I'd like you to look over. Now, this code represents a job site, as in a place we're doing some construction work. Oh, we're cutting off the top of the screen, huh, a little bit? Let's go up here. There we go. Now, all job sites have a location, because you're always doing work somewhere. But not every job site is going to have a contact. Contact could be nil. That's optional. We might not know who the contact is at a particular job site. So notice I've just described something implicit about this code, right? It's not obvious from looking at this that a contact is optional, but you can start to see it at these ugly conditionals. Look what happens if I want to pull up the contact name. I've got to check for the presence of contact. Otherwise, I provide a default. Likewise with contact phone. And if I want to email the contact, I have to make sure he exists first before I try to call a method on it. So how is this code? Well, this code's OK. It's not great. What's the problem? Well, it turns out, in a slightly more hidden way, we're still violating tell don't ask. Or we're violating tell don't ask again. So we're actually, every time, we ask contact something. We say, hey, do you evaluate to a truthy value? And if you do, I know what to do. And if not, I'll do something else. So what we'd rather do is just send contact.name. Tell me your name. And if you do exist, return what your name is. And if you don't exist, tell me no name. So what's actually happened here is we've co-opted nil. Because when contact doesn't exist, @contact will be nil. And so I'm actually passing around the nil object, the nil singleton, as my contact. That's not a very good idea. And it leads to this ugly conditionals, like the one on 12. So how do we prove this? Well, oh, and one other bad thing. This obscures the point of the code. Right? Contact.name really just cares about the contact's name. But I have this annoying handling in here. It's making it harder to actually see what this code really does. So the way around this is with a pattern, reasonably common one, called null object pattern. So rather than have nil stand in to mean when there is no contact, I'm going to actually create an explicit object to stand in for that case. And since this uses the null object pattern, and I believe it's a good idea to actually use pattern names in class names, which some people want to fight to the death about that one, I'm going to call it null contact. So if we don't actually have a contact passed in, assign a null contact.new. Let's run our tests. Whoops, got the wrong test going. Boom, and things blow up. The first error was that there's no null contact. So let's make that happen. Now we have more errors. And now what's happening here is I have tests that don't pass in a contact. They just pass in nothing. And so it's assigning a new null contact here, but then null contact doesn't respond to things like contact.name. It's just a brand new class. It's got nothing on it. So let's add these things. We're going to add name, we're going to add phone, and we're going to add deliver personalized email onto our null contact class. So here's name. Just when there's no contact, the thing I want to return is no name or no email. Deliver personalized email takes a email body, but I'm just going to leave it blank. I'm not going to have it do anything, because if there's not a contact, just do nothing. So if I run this, notify method phone. Oh, phone, right? Phone? Yep. OK. Back to green. And now, we're green, but what can I do now? I can do what every programmer's favorite thing is, which is what? Delete code. No one ever fails to know what that is. That is so universally the programmer's favorite thing. Everyone gets that. So let's delete some code. Oh, yeah. Oh, yeah. Oh, my God. And we're still green. How great is that, right? Yeah, thank you. That guy likes null contact a lot. Me too. OK, so for the cost of this stupidly simple null contact class, I've blown away 3 conditionals, yanked out about 12 lines of code, made these methods more obvious and more direct. All for the cost of one little class. Also notice, we're no longer violating tell don't ask. We always tell some sort of contact, yo, dude, I need your name. We never care about whether it's an actual contact or a null contact. The client code doesn't know, and it doesn't care. So that's awesome. This is actually a great win. This pattern, it's simple, but once you understand it, you see opportunities to work with it all the time. And it's great. Now, there is a downside now, right? What's the downside? Yeah. Now I basically have to keep 2 APIs in sync, right? If I add new methods to contact, I'm going to need to add them to null contact as well. That's a bit of a pain in the ass. But it turns out it's generally worth it. A lot of code ends up with these big, hairy, nasty conditionals, and null contact just like destroys them like that. By the way, this refactoring is called replace conditional with polymorphism, which means rather than doing ifs, just send that same message to multiple different classes. That's polymorphism, right? You just always send a message to varying different types of objects, and objects know how to respond to it in different ways. So there's a bit of a cost to this, so you have to weigh that to see if it's worth it. Nothing I'm teaching you today always works. There's no refactoring that is always a great idea. You always have to say, is this worth it given the components of my system as they are? So that's the downside. We talked about the good sides. There's a lot going on. How many people, by the way, have code in a Rails app that looks like if current user, yada, yada, yada? Raise your hand. Yeah. Can you see how this would apply to that? So rather than have current user return a user object or nil, and then constantly need to check if current user is nil, have current user return a user or a null user. Yeah?
So now that you've discovered this null object,
Yes?
do you, like you've gone one step, and now this null object is a concept inside this class.
Yeah.
And consumers of this class are still allowed to pass in nil, and the right thing happens.
Yes.
Do you tend to leave these null objects inside of the class where they operate, or do they become domain concepts that other classes integrate?
It's a great question. So the question was, null content is defined in this class. Do I leave it in the class, or do I pull it out and make it sort of a first-class citizen in my business logic? And the answer is it varies. Usually with something like a null contact, I will pull this out. I'll put it in app models. I'll call it nullcontact.rb, It will live as a top-level important class in my app. Occasionally, I will define classes that only live inside the context of like one other class, right? So like if you are being aggressive about extracting small classes, like Bob Martin says you should be, there are times where you'll find that you've written a small class that's really just like a little data container or something very basic that's only used in one class. And in those cases, I'll just leave that class inside the original parent class. I'll even make it private so I know nothing will ever talk to it. It's just for that top-level class. By the way, in that case, I wouldn't write explicit tests for that class. If it's private to another class, I'm not going to test it. I'm not going to test private methods ever, actually. Nothing that's private. But if I do promote it into be a top-level class, then I am going to write separate unit tests for this to make sure it works. It's a great question. Other questions about this? Or anything else? All right. We got one more example, and then a quick wrap-up. And I got some recommendations and things like that. So onward and upward. Let's go to this guy. Take a second and read this code. Okay, so let's talk about an idea called depend upon abstractions. Now, most programmers are aware that it's a good idea to depend upon abstractions. So most people will use, for example, active record to have it generate SQL for them rather than write SQL by hand, unless you're in a horribly ugly situation where sometimes that's the only way out, but hopefully you don't get there. Also, most people won't just shove bytes into a socket. They'll use a library like NetHTTP. So most programmers are aware of this idea in general. Like you'd rather keep pulling up a level of abstraction. And you'd rather depend upon those abstractions than particular implementation details. For instance, that's why you pull a lot of stuff to be private inside an object. You don't want other things outside that code to depend on your internals. You want to depend on an abstraction that you're providing. The thing that a lot of people don't realize is that abstractions are fractal. You can keep going higher and higher. And you should be relatively aggressive about creating abstractions within your application. One great rule of thumb is that you want the whole to be simpler than the sum of its parts. That's a great rule I took from a book called Growing Object-Oriented Software Guided by Tests, which has the longest book title I've ever recommended. I'm going to show you a link to that later because it's an awesome book. That's a great rule of thumb. The sum should be simpler to work with than its parts. So if you've got a few models or a few classes in your app, wrap a class around that bad boy. Make a simple API that's easier to use. Create an abstraction that your other things can depend upon rather than the low details within your app. One place I see this violated a lot is ideas like this. So I have all this code here, and this code is concerned with charging people for things. Braintree, by the way, is a payment processor. So I pulled down the Braintree gem, which is good. It's better than writing direct calls to Braintree's API, shoving bytes down a socket. I've extracted a bit, or it's using an HTTP API, but my code doesn't know about that. It doesn't know that this is an HTTP API, which is good. We've gone pretty far. This is nice. It's not great. Notice that user is concerned with things like, how do I find my own Braintree ID? And then once I do, how do I charge for a subscription? And how much should I charge? Or how do I create myself as a customer with inside Braintree? And then refund is concerned with other problems. How do I find the transaction ID of the thing I build for? And then how do I refund that? So we're depending upon the Braintree gem as an abstraction, but we can go more abstract than that. This has some weaknesses right now. If I wanted to change which gem we use to build with Braintree, I suddenly need to open up user. That seems like the wrong thing, right? Oh, I need to change which payment processing gem I'm using. Therefore, let me open up the user class, right? That's a great smell. There's this idea called shotgun surgery, where if you need to make a change in your app and you need to open up 30 files, you're doing surgery with a shotgun, right? You're blowing code everywhere, you're affecting everything, you're breaking stuff. It's so much more likely that you're going to break things. You're going to do it wrong. Wouldn't you love to just open up one file and change your payment processing gem there? Yes, you would. Isn't it likely that you might change payment processors? Yes, it absolutely is. I've done it before. Here, we have to open up all these classes. So how do we improve upon this? Well, I would do something like this. I make a new class, as you might have guessed, I love classes, called Payment Gateway. I've moved that constant inside Payment Gateway. It's a nice place to hang it. And I set up my gateway, which by default is Braintree Gem. And I move that logic in there. And then my client code, this stuff, only knows about Payment Gateway and the method names, and it just passes itself in. Now, all that logic lives inside Payment Gateway. It hasn't leaked into my application. If I want to change payment processors, there's only one file that needs to change. That's the power of depending upon abstraction. One file needs to change when I'm going to make a change, not shotgun surgery. That's actually a really big win. It makes it easier to change stuff, which is the thing that really matters. Finally, notice now, if I want to test this guy thoroughly, I have to stub methods on Braintree Gem, which is a great way to make yourself want to have a bad day. You're going to have a bad time. If you stub other people's methods, you're going to have a bad time. Braintree Gem, its API is reasonably likely to change. You update versions, your tests are stubbed out, you don't realize those methods have been changed until you run this thing in production, and it blows up, and you can't bill people for stuff, and people are really upset. In this version, you can stub your own methods. If you stub your own methods, you're going to have a good time. I'm totally fine stubbing out charge for subscription or create customer because I control them. So this thing just got easier to test with the introduction of a new abstraction. That's a great sign. That's a positive code smell. When you're writing your tests, pay attention. They're telling you things. If it's hard to test something, if you have to do something that makes you feel dirty, don't do it. Listen to those tests and instead figure out how you can test it and figure out a change you can make to it to test it in an easy and straightforward way. I don't always do things like this. But when I notice that I've got the concerns of billing spread out through the app, I'm pretty likely to do it. I don't like to see things like gem names popping up, or gem class names popping out through all my business logic. I'm just concerned that this is a payment gateway. I'm not concerned that I'm using Braintree to do it. Depend upon abstractions. Okay, so we've talked a bit about some different ways of refactoring. So when do you refactor? Well, the best time to refactor is when you want to make changes to the code. It's actually rare for me to just be like, wake up on Monday morning and be like, you know what? I'm going to refactor some stuff. There's that user class that sucks. I'm going to refactor it. Now, part of that is because I'm a consultant, right? And consulting code is a little different than product code. If you're a product company guy versus a consulting guy, like at the end of every week, I need to point to stuff that I've done and that justifies the value that I've just charged for. So there's a bit of a paradigm situation there, which maybe doesn't match yours. But I don't just wake up and say I'm going to refactor stuff. But when I need to change something, I am very likely to go refactor it. So Kent Beck had this great tweet, which is, if you need to make a change, refactor the code so that the change is easy. Note, this part might be hard. Then make the easy change. It's a great way of thinking about it. When you get to some code and you think, oh man, I got to change this widget to take a foo widget instead, think about how you can make the change that you're about to make really simple and straightforward. Refactor it that way, and then make your change. So don't just refactor willy-nilly, especially if you're a consultant. Okay, so that's a great time to refactor. What are some good things to refactor? What are good candidates for refactoring? Well, my favorite things to refactor are God objects. Now, what's a God object? A God object is a class in your system that everything seems to rely on, or everything seems to interact with. And a great rule of thumb is that Rails apps almost always have two God objects. The first one is user, and the second one is whatever that app is about. So if it's a to-do list application, the other God object is what? To do. If it's an e-commerce application, the other God object is what? Order. Exactly. Two God objects, at least. Some apps have more. The bigger they are, the more likely you've got a handful of God objects. So how do you find these God objects? How do you be aware of them? Well, a great way is to walk into your app models directory. I've anonymized this one to protect the guilty. Let's get a word count of lines of every object, every model of ours, and then let's sort them. And you'll see that I'm not totally crazy. This is an e-commerce app. How can you tell? Well, user is a God object. Order is right behind it. And this one actually kind of has 3. Merchant is arguably a God object. Do you think a 600-line class has only one responsibility? Probably not. You've heard of the single responsibility principle, right? Every class should only have one responsibility, a singular responsibility. The first rule of classes is that they should be very small. The second rule of classes is that they should be even smaller than that. This app is violating that. User is huge, and because of that, it is a pain to work with user. So when I'm working with user, I refactor it. If you want me to change something about user, I'm going to make damn sure when I push up those changes, user is smaller than when I started. I am extremely aggressive about refactoring responsibilities out of God objects. I don't want user to get any bigger. I want to get it smaller. Same thing with order, same thing with merchant. It's a great way of thinking about these things. Be aware of your God objects and be completely reluctant to add additional lines of code to them. It's going to make your life a lot better. Where else is a great time to refactor? High churn files. What's churn? Churn is when you're changing a file a lot. I keep having to come back to user and change it, and change it, and change it, and change it. Pay attention to that. How do you notice that? Well, maybe you just notice it, but maybe you use a gem like this. It's a gem called churn. This will look through your Git history, or SVN if you're crazy, and it will tell you the files that change the most. If a file's changing all the time, it's because you don't really understand it. It's a great candidate for refactoring. You want to make it easy to change that file in the future. So give it a good hefty dose of refactoring. Another great place to look for refactorings are files in which you find bugs. And you know why? Because bugs love company. If there's a bug on line 10, chances are there's a bug on line 11. And the reason is the code was too complicated for you to understand it. That's why the bug is there. It was too hard for you to see the bug. So if you've got a file where bugs are showing up all the time, refactor it. Make it easier to understand. Give the bugs fewer places to hide. So that's when I like to refactor. So a couple recommendations before I go. First is, if you haven't read this book, read this book. This is about the best, like intermediate to advanced to sort of advanced beginnerish book for general programming knowledge. Like it's just great. Read this book. After you've read that book, read this book. There's basically nothing I talked about today that isn't in this book. This is the Bible. You've got to know this book. You should know the names in it. You should know the techniques in it. It is wonderful. Also, these two guys, Bob Martin over here and Martin Fowler over here, are just the best damn software authors there are. No one writes about software and programming better than these guys, in my opinion. Finally, this is a great book. This one is like the least known of those 3 books. The other 2 a lot of people have read or at least have heard of. This book is sort of an unknown. It's awesome. It's a beginner book. It's an advanced book. It talks about the ideas in OO programming and TDD that I sort of roughly knew implicitly, but very cogently, very explicitly. It made these ideas make a lot more sense. It presented them in ways I'd never thought of and gave me a lot of really good rules of thumb. So check out those books. Refactor when you got to do it. Write some good code. Thank you.